See, electric power. This is a topic of current electricity. So, power equals to, we know that rate of doing work or energy. So, energy by time, or we can say work by time is power. What is SI unit? Watt. First, we should know about energy. So, for that, we use potential difference formula. Potential difference is equals to rate work done per unit charge. Now VQ equals to work. So VQ equals to work. Now we know current is equals to charge per unit time. So you can say Q equals to IT. Using this Q equals to IT here, we got work equals to VIT. This is a work or energy formula. Work and energy both have SI unit joule only. SI unit joules. Now, using this, we can write power equals to VIT divided by T. TT will get cancelled. So, power equals to VI. This is first formula of power. Now, using Ohm's law, we say V equals to IR. So here using Ohm's law, power will equals to I R into R, that is I square R. Using Ohm's law, you can also write from here, we can replace I. So I equals to V by R. So you can say here also power equals to V, and in place of I you can write V by R. V by R. So you got V square by R. So we have three formula. In this summary, you can say that energy equals to VIT. This is first formula. Energy is also I square R T. Energy is also V square by RT. This three is energy formula, and power equals to energy by time. So power is equals to VI, power is equals to I square R, and power is equals to V square by R. This actually it looks many formula, but you have to know just basic formula. Power equals to energy by time, and you know this potential difference is work by charge. So from here we can get all the formula. Based on this, we will do the important question, which is little confusing for students. That question is brightness. Brightness question, which they ask in MCQ sometimes 3 marks question every time in board. So let's talk about that. Suppose you have two bulbs connected in parallel, having 2 watt power, 3 watt power, and potential difference is 6 watt, 6 volt. So now, which one will glow brighter? So in parallel, if they ask question, you are lucky. There is no confusion. If they ask in two bulb connected in parallel, they may also ask this one bulb is, for this last year question, 40 watt, and here you have 60 watt. And if they ask connected with 220 volt, which one will glow brighter? So we can directly say more power in parallel. Remember, in parallel, if it has more power, it will glow more. No confusion in that. But if resistors are connected in, if two bulbs are connected in series, so we have to find resistance, because bulb has some resistance, it's also resistor, one kind of resistor. So in this case, we cannot say, I will give you trick, but before that you should know the logic. So if suppose this question comes that two bulbs are connected in series, now what will be the brightness? When we write here 2 watt, it is design power rating, it's design, means this bulb is designed to work on this power. But when you connect in the series, the power only gets changed. That power we have to find out. So this question is important to understand. Little confusing, but if you use brain, it will be easy. This question. So here, first we find resistance of both bulb. How to find resistance? For that, we consider that bulb is connected in parallel designing time, like it's designing time, how we connect, how we design it, we give some rating. This is power rating. So suppose we connect with 6 volt and this is 2 watt. Designing, if it has to work alone, means it is designed like that. So from here we find resistance. How to find resistance? Which formula to use? Now for some students there is a confusion that which formula to use. This formula or this formula or this, out of 3 formula, which formula to use? Of course, this you cannot use because here there is no resistance. Among this and this, we say that whenever is connected in this way or in parallel, you have to use this formula. P equals to V square by R, because voltage is same. If voltage is same, you can find the, whenever it is connected in parallel, you can always use this because voltage is same. Whenever it is in series, you have to use this one. But whenever it is design resistance voltage we have to find, we have to use this. So we can say P equals to V square by R. So what is P here? 2, and V is 6 into 6 by R. So you will get R equals to 6 into 6 by 2, that is 3, 18 ohm. We got 2, R2. R2 means the resistor of bulb which has resistance, which has power 2 is 18 ohm resistance. So R2 we got. Similarly, we can find same way, we can connect this one with 6 volt and 3 watt. So we can say R3 is equals to V square by R. What is V? Again same, 6 into 6 by 3. Power is 3. So 3 2s are, then 6 2s are 12 ohm. So we got R2 and R3. Now important point is whether it is connected in series or parallel, resistance of individual will not change. We can write here resistance is 18 ohm and here resistance is 12 ohm. If resistance is 18 ohm here and 12 ohm here, we can find the total current because by using Ohm's law. So we can say R equivalent is equals to R1 plus R2, so 18 plus 12. So you will get R equivalent equals to 30. When you get R equivalent 30, you can find V equals to IR. V is 6, I is, we have to find, R is 30. Now 6 by 30 equals to I. So you got I equals to 1 by 5. You got I equals to 1 by 5 ampere. Now what to do? We can find out if current we know that in series means same current, means we know that 1 by 5 ampere current is passing through this. If 1 by 5 ampere current is passing through this, we can use now this formula P equals to I square R to find out individual power whenever it is connected in series, because I said you that whenever it is connected in series, the power will get changed. In parallel it will not change, but in series it will change. So if it change, what we have to do, we have to find power of this and this after connecting in series. So can we say that P equals to I square R. So power of this earlier which has 2 watt individual, now in connection it will have I square. I square means 1 by 5 into 1 by 5 into R. What is R? We got R to 18. So you'll get 18 by 25 watt. And P3, how much you will get? You will get I square R again. So same current because both are in series. And R you got 12. So 12 by 25 watt. You see, power got changed whenever it is connected. Earlier it was 2 watt, 3 watt. Individually, when connected in series, power got changed. Now 18 by 25, 12 by 25. Which one is, which has more power? If I ask you which has more power, you will say that denominator is same. So numerator is more here. So you will say P2. P2 means earlier it has 2 watt, but now it has 18 by 25 watt, means P2 is greater than P1. Means earlier it has less rating, but connected in series now it is more power. Means the bulb which has less power rating will glow more in series. This is very important, you can write. Since power of P2 is greater than 1, so P2 is greater than this 3 because earlier it was 2 watt. Now this one will be glowing brighter. This will glow more. So you can make it point, which is very important. In series, if power is more, it will glow less or dim. And if power is less, power rating is less, it will glow more. So in this case, this will glow more because it has less power. Why? Because power depends directly proportional to resistance. This is very important concluding point of today's class, that power here in series is directly proportional to resistance, and in parallel power is inversely proportional to resistance. So since in series is directly proportional to resistance, we can say if resistance is more, power will be more. So where we got more resistance, we know 18 we got here. So here we got more resistance. That's why in series, if more resistance, more power. And in parallel, it's very simple. We can take our example in our home. If we want bright light, we get more power rating bulb, because in parallel, if more power rating, it will give more brightness. I hope today's class is clear. Thank you.